Hello guys, so I recently saw this Instagram post where Roger Kilimanjaro, hope pronouncing name right. So basically it's a vase and then droplet comes and basically like growth starts and it slowly transitions to the gold material with these nice ripples, and I thought I should repeat this effect and maybe in the process improve it a little bit, because I saw some of the artifacts here. For example, when they transition it back, there is some leftovers, like this example here. It just like fades out, and I'm not sure how he made this. I think it's a cinema with the follows maybe, and then the transitioning done with the waves in Redshift. But we're gonna go with the Houdini, of course. It's procedural, it works with any geometry, and of course it gives you, in my opinion, a little bit more organic look. As you can see, also spheres drop, they are just cover the surface fully, and of course there's nice ripples as well, and there's a render for this, of course. So there are some sparkling particles, and it just, this nicely organically transforms into a gold shader. So that's what we're gonna basically build today. So if you want to get the my Houdini scene file for this final render with all this stuff included, you can buy this from Gumroad. It's $2, not free, but it's basically the same thing as I show you in this video. It's just like pre-built and include all the rendering stuff. So if you want that, you can get this from my Gumroad. Link would be in the description. Let's start building this setup with more easier and simplified version. Then we're gonna transition to more like complex effect. So we're gonna start with the grid. Let's set it to like 10 by 10, and then increase the rows and columns. So we have this type of grid. Then we're gonna use a fast remesh node. The reason for that is basically we want evenly spaced topology, and then the fast remesh, why we're gonna use this node is that it's a lot faster than just remesh node. And why it's faster? Because it's actually segments your geometry into like those buckets like you have, for example, in Redshift. So we're gonna untick the connectivity, and then we're gonna take the target bucket size, so we can visualize this. So if you just press the visualize segments, you're gonna see this type of stuff. And what you need to do is, let's set this to smaller value, so something like this. And then you can see it's not like even. So what you need to do is you need to increase the remesh iterations here, and then let's decrease target edge length to something like this maybe. So we have around 11,000 points. So let's move to the next step, is to use a scatter node. For now we're gonna just scatter 1 point, and this will be where our infection is actually gonna start. So let's drop down the wrangle node, and then we're gonna call this wrangle node set infected, for example. If we dive inside, we can use a distance. So what we need to do is we need to calculate distance between all of those points positions to this one. So for that we're gonna use distance node. We're gonna pipe the position of all the points into the first input, and then we're gonna use a function called near point. This near point function can just retrieve the point numbers of this point. So it basically outputs the nearest point number, sorry. So we're gonna just use the second input here because our scatter is wired into the second one, and then I'm gonna use import point attribute. I'm gonna pipe that point number into the ptnum, and you can pipe this file into the second one, or you can use a input here parameter and just select the second input. I like to do this because it actually creates less visual like trash in the view in the network, so it's a lot easier to read what's going on. Then I'm gonna just pipe this to the point P2, which is point positions. So what we're gonna get out of this, we're gonna store this to the attribute. You can just visualize this. It looks like this. So basically it just calculates the distance from this point, and then we're gonna output this to bind. We're gonna use bind export, and we're gonna output this to attribute called infected. Let's cut this, we don't need that, and let's set up some visualizer. We're gonna call this viz infected, and then we're gonna use a ramp. We're gonna select our attribute, and I'm gonna use infrared, so we can see the range a little bit easier. So what you need to do is we need to select on this or geometry. We're gonna just select some points around this scattered point, so we don't want the whole basically whole distance. We just want like around this minimal area. So we're gonna use fit range, and we're gonna first of all invert this, so it starts with this value of 1 and then fades out, and I'm gonna just clump this in a little bit, so you can see that some of the points are selected, so basically only those points have some values. So this is the first step, and then you can just increase this total count, and you can see that those points just get masked, and that's like first step of our setup. Somehow we want to actually propagate those values to the rest of the geometry, and to do so we're gonna of course use a solver node. What we need to do is we want to move our set infected node to the solver, to the inside of the solver, and then here we're not gonna use previous frame for now. We're just gonna connect first input, which was our geometry, and the second input, which is scattered points. Let's set this back to the 1 for now, and we're gonna use the input 2, which again is our point. So this is the first step. The next step is actually the accumulation, so let's pipe the infected into first point and then the previous frame into the second. This is where we're gonna accumulate all of those points. So let's dive inside. We're gonna get or infected, so we're gonna say infected, and we're gonna set this back. So basically I'm gonna use bind export again, and then we're gonna call this again infected. So basically what we're doing now is we're just reading this value and then outputting back. So when you are inside the solver, the preview is not gonna work correctly. So what we need to do is we need to go back. We're gonna pin this viewport here. So now our viewport is always gonna output the result of this network, and then we're gonna dive back in, and then we can do stuff. So for now, as you can see, nothing happens because we did nothing. So what we need to do is we need to like look for the points around the surface. For that we're gonna use a PC point cloud open. We're gonna pipe the position, and then here is a important point. So what you need to do is you need to use not current like point, but we're gonna use the previous frame here. So we're gonna pipe this to the second one, and then we're gonna filter out. So basically we're gonna import our infected attribute. So let's call this infected, and then what you need to do is you need to add this value back. So basically we are for each point, right? So let's say you have this point right here. So let's say you have basically this point, and in this radius it actually looks for the other points. In this case it's actually like 10 points, you can see here. So just 10 for 10 points in this radius, and then if it finds within this radius a point which has this value, infected value, then it will gonna get this value and transfer to itself. And we're gonna do this basically each frame. So because of that, basically this whole stuff is gonna like propagate along the mesh. So let's see what we get. You can see it's kind of working. We just need to up the search radius, and yeah, basically we get something like this for now. We're gonna just multiply this. We're gonna multiply this like a 0.5 for example, and this is basically what you get. So what I found out that these values are they are enormous. So because we're actually adding each frame, of course our value is not gonna stay normalized. So what I did is actually the next step of this tutorial. In this step we're gonna introduce the second attribute that we're gonna use, and for that we're gonna use wrangle. Let's call this set age, and then the result of accumulation goes into first input, and then this goes to the second one. And here we're basically gonna say if our infected attribute is bigger than 0, what we're gonna do is we're gonna set this age attribute. We're gonna do plus equals, which is basically gonna add each frame. What we're gonna add is we're gonna add the our age. So it's basically we're gonna get this from the previous frame. So we're gonna say point 1, which is the second input, and then age, and we're gonna look for ptnum, which is current point numbers. I'm gonna say +1. So what we're gonna do is we're gonna basically get this age, which is gonna be set up in the first frame. We're gonna add all the previous ages, and we're gonna add as well 1. So it basically will grow as the infected attribute grows. So let's copy this node. Let's call this age. Let's visualize this. So this is what we get. You can see it's really harsh, but the cool thing is that those values are more normalized than the previous one. So what we can do with this is we can say, for example, the range is from 0 to 40, and then you can see that this is more like controllable, because we can control this one. Because if we say like a 10 here, you can see that like this fall off width we have, it's just basically constant. So we don't want that. We want more control. So because of that we set up this type of stuff. The main downside is we get some of those artifacts, which we're gonna fix eventually. But for now there is one more thing that we're gonna do, and that is basically we're gonna say in the solver we're gonna not compare this to, we're gonna not say this more than like so basically infected bigger than 0, but we're gonna just use a little bit of values. So we're gonna say 0.035. This is the value that I found, which works quite well. And so as you can see that this thing becomes more spherical, as if we revert back this, you can see that it's not really spherical. So we're just gonna a little bit of threshold, and then basically have smooth value. So this is cool, and let's go to the next step. Let's actually set up some more of the dynamic points here. And the thing is with this one is basically if we start adding those points, so let's say we're gonna do $f divided by 25. What this means is gonna start with the 0, and each like 25 frames you want to introduce 1 point. So this is kind of what we need for now. Let's see the result. And you can see the result is not great, because for some reason, even if we don't have a point, it still outputs like this value, but we don't have anything there. So let's investigate. And the reason why it's happening is because of this node. So in here we can see that we are basically comparing the distances between the points that we pipe into the second input, and then between our points. But what if there is nothing like piped into the second input? What happens then? So that's the reason why it's actually happening. What we need to do is we need to just create if statement. We're gonna do this with the switch if. So if basically we're gonna connect this like this. So, and what we need to say is we need to say if there is no points in the input number 2, then please do not execute this node. So this is basically what I'm going to say. Switch if ptnum is switch if ptnum is less than 1. Basically this is what we're going to say. And this switch if node quite good. What we need to set is, first of all, test input should be spare input. So we're gonna test this node. So we're gonna just pipe this here, and in the test type we're gonna say element count, and we're gonna say number of points is equal, so is less than basically 0. And if we look at this, so let's say now we have 2 points. It's still for some reason, so basically less than, let's say greater than 0. Yes, there you go. So you see these wires. So basically now it's selected this input, but so the viewport is currently glitching out. But if there is no point, you can see that this node goes through. If we have some points, for example, now the input is the second one. So this is the fix. And if you look at the result, you can see that like in the first frames we get nothing, and only when the point actually starts like happening, only then we get something. So there you go. It just spawned here, first point, and then propagation is actually happening. For now, let's actually lower down the target edge length, and let's see the result. So as you lower down the edge length, the propagation will be slower in terms of speed, because more points, of course, you need to like propagate along more points, and because of that it's slower. But now you can see the effect is working. So basically have this adding points, and then they add and they just propagate. So that is basically the simple version of this whole effect. You can see, and they all disperse quite nicely, you can see here. So yeah, let's now build the dropping points on the surface. So before we go to the next step, let's actually change up this geometry to something more not difficult, but something more complex. Let's use a big head. I'm gonna turn off the shader, we don't need that, and we're gonna use clean node to get rid of some of the attributes. For example, if you look here, there's a strange artifacts around the eyes and some of the other places as well. That's because this fast remesh internally recognize the UV attribute, and we don't really want that, so we're just gonna remove this and untick the other boxes. So now you can see that this artifact is actually gone, so it's now evenly spaced. We can also use a little bit of smoothing, and we're gonna decrease this target edge length a little bit more. So let's use something like this, and then what we need to do in order to get rid of those artifacts, we're gonna just use a subdivision here. So if you subdivide this once or even like twice, then you get smooth geo with nice triangles. So let's see what we get. So 1, 2, 3. So it's growing, it's cool. So first of all, let's fix these artifacts. So we're gonna first of all use attribute blur, and I'm gonna say blur age, and I'll say age, blur this, and I found that the iteration 1 or 2 works quite nicely. And also we don't want this infected attribute anymore, so we're gonna just remove that. So delete attributes, infected, so let's call this delete infected, and then here let's set up some null, and this would be in geo. So this is the setup. Let's set up these dropping points. Now for this type of geometry, what we need to do is we need to mask out the upper parts of the geometry. So we're gonna use mask by feature, and here we're gonna just select basically like how you can call this, basically y direction. So we don't want to scatter point inside of his mouth, because that way it can drop through the nose and to the mouth. Yes, I hope it's clear. And here I'm just gonna remove the animation attribute here. We're gonna just put down like a 6 points, for example, and we're gonna use this mask in the density. So that's it, and then we're gonna use enumerate node. We're gonna add IDs. We're gonna use that later. For now, it's not really important, but still add this. And then you're just gonna use a triangle node. I'm gonna create attribute called a drop frame. In this attribute, we're just gonna create some attribute. Basically, gonna tell in which frame these points are gonna drop to the surface. So this one is actually like a constant drop frame, so it will drop 1 point each, like 25 seconds, for example. So for that, just use ptnum, so current point number, then multiply this with the channel. This is basically emit nth frame, so basically emit every frame that we specify. So let's emit this every 25 frames, and let's just use a spreadsheet. So you can just right mouse click and just use spreadsheet, and it will pop up the geometry spreadsheet. And this is our drop frame attribute. So you can see that the first point is actually drop on the frame number 0, number 25, number 15, and so on. And you're gonna get this clearer view of what we're doing just in a second. So let's call this drop frame, constant drop frame, and then we're gonna use a WOP attribute WOP, and this will be our like a logic. So let's turn on in the scatter relax iterations, and then let's just preview this template flag or initial geometry. So here's our points, and I'm gonna drop this. So let's call this drop logic swap. And then in this swap, I'm gonna just basically get the points, and then I'm gonna say set vector component position, and then here let's set the second input, and then let it be parameter. And in this one, this is basically y position of points. So y position, and then let's place them let's a bit higher, for example on 4, and then they're gonna drop to the surface in a moment. For dropping, we're gonna use mix node. We're gonna mix between this thing and then the original point position. And then if you just visualize this, you can see that we're just mixing between those two positions. And then we're gonna take frame, we're gonna say subtract. What we're gonna subtract is actually our drop frame attribute. So let's call this, let's import our drop frame using bind. I'm gonna pipe this into the subtract, and let's see what this gives you. So you can see each 25 frames, it's just gonna lit up, you can see. And this is basically what we're gonna use. So let's connect this to bias, and let's see what's gonna happen. So they are disappearing for some reason, and the reason is being that we need to clump this. So it's only from 0 to 1, not like 0 to 100 or whatever frame it is. So now you can see they are just randomly dropping points, but this happens in an instance. We don't want that. We want to have a little bit of some timing, and for that we're gonna use this source max attribute. So let's promote this again, and let's call this drop time, and this is basically tells you on how many frames it's gonna take to perform that drop. So let's go drop time, and then let's set this to 6 frames. So in 6 frames, one point is gonna drop. One, you can see the transition between the upper space and then between the target's position is in the 6 frames basically. If you say 25 frames, which is 1 second, it's gonna transition in a 1 second. We don't want that. We're gonna just want this to 6 frames, and that's pretty much it. And then we're gonna update this drop frame attribute. So what we're gonna use is we're gonna just basically to this drop frame, we're gonna add this drop time. So if you add this, the reason is basically we want to split those points where they are like in the middle of transition, and then when they are basically hit the surface. And for that, because we want like the final position, so we're gonna plus this drop frame or drop time, and then we're gonna output this with the bind export. And bind export, and let's call this drop frame. And this drop frame, next up we're gonna use this, and we're gonna group points that are already dropped. So let's call this group if not yet dropped. And then in this we're gonna say if our drop frame is bigger than current frame, then we're gonna set up a group. We're gonna set up group called split, which is gonna be equal 1. And if you visualize this group, so we're gonna say visualize output selection group split, you can see that points are which is not yet dropped will be the higher points, and when they are dropped, they're gonna go out of this split group. So if you see drop, basically the yellow ones in the group, the white ones is not in the group. So this is why we added this drop time back to the drop frame. If we don't do this, you can see that they go out of the group as fast as their drop time starts. So you can see that they are in the rest position, and as long as they starts to falling, they go basically out of the group. We don't want that, so that's why we added this drop time. So now let's just split this. I'm gonna say split if not yet dropped, and I'm gonna just select the split group. So here we're gonna just invert the selection, and each point which is already dropped would be in this group and will go into our solver. Let's call the solver accumulation solver, and let's see the result. We can merge this so we can say let's merge this back, and let's merge this with the geometry. So I'm gonna use merge backed because it's faster for like merging for the visualization. So I always use merge backed instead of just merge node if I'm just visualizing. Okay, so if I actually need to merge stuff, I'm gonna use simple node, but for this type of stuff I'm just always use merge backed. So you can see point drops, the propagation starts. So that's basically the effect what we're looking for. Let's lower the edge length, and then let's see what we get. Drop. So it's too much. Let's go back, and then let's just in the accumulate, this constant we're gonna just use 1.2, so the growing would be a little bit more slower. So yeah, this is basically it. You can see that those are points, they still dropped, but they have like nothing to grow because it's already like grown. So of course you're gonna have to find something more reasonable for this, because I usually, what I did was I just removed this whole setup and I just set up a blast node, and in this blast node I'm gonna close blast manual selection, and I just go here and I just select the points where I want to have. So for example, let's select this point, this point, this point, this point, and then maybe this point. And then let's say delete non-selected, and you're gonna have these 4 points, and you just pipe this to the enumerate, and then you're gonna have your result. So you can see you just basically manually selected all the points you need, and it grows quite nicely. So in this next chapter, let's say we're gonna set up the like this waves and like finalize the effect. Right now we're gonna finalize our setup. We're gonna just add a VOP. So we remove the visualize edge, and then let's call this add waves and mix surfaces. In this, let's basically get the age back. So I'm gonna say age, I'm gonna say fit range this, and then let's create ramp for now, where we can basically better visualize the values. So you can see the edges is quite harsh, is because we need to set the ranging. So the source max, I found that 20 works quite nicely, and then let's promote this 20. So let's get this, and let's call this file off width, because it basically controls the width of the fading. And let's reset up the range, and so this is the basic of it. And then what we need to do is we need to output this to the bind export. We're gonna output this to the mask. So this is basically going to be our mask. And let's use color mix. This is again, I guess, for just visualization. Let's use that. Let's first color set up some like dark one, and then the secondary, which is affected, going to be red in my case. So now we want to displace the geometry. So let's use displace along normals. Let's connect the position, and let's output the displaced position here. So let's again take the edge. Let's wire this to the sine node, and the sine node basically gives you this type of stuff. So because we have infinitely like a large range of this edge attribute, so it basically goes till the infinite, and because of that our sines would be nicely animated, as you can see. So basically they are just grow out, and this is what this setup like actually built upon. And so we're gonna just multiply this edge, so we're gonna lower down the values because we don't want this type of waves, so it's just too frequent for me. So let's use multiply. Let's again promote parameter, and this would be waves frequency, let's say. So waves frequency, and let's set this to a value of 0.1. And then what you need to do is basically those black areas are the values of -1 to 1. Basically I'm bringing this spreadsheet like this because I have a shortcut for this spreadsheet to Alt S. You can set this yourself as well in the hotkeys manager. So basically that way I can easily bring the spreadsheet. I don't like to have the spreadsheet always on. I just bring this up when I need. Basically that's it. So what we need to do, we need to bring those negative values back to the positive, and I'm going to use absolute node. So that way you just basically have this waves. So let's increase waves frequency, for example 0.25, and then we're going to use another node. So first of all, let's visualize the displacement. So the displacement, let's say 0.05. We can also promote this value. We can say displacement scale, for example, and then let it be 0.025. And so you can see that the preview of this viewport is kind of weird. That's because we're gonna need to update the normals, and if we update, you're gonna see that we actually have waves that are actually growing like this. That's quite cool, but we don't want to have them at the geo. We just want them when the transition happening and then just disappear. But before we start doing that, let's use a smooth node. The smooth node is basically applies like a ease in and ease out to your values. You need to connect the output of this absolute node to the amount, and then you're gonna connect this to the amount of displacement, and nothing happens almost. But if you start to adjust this roll off, you can see that you can basically control the mixing of this roll off, and that's quite cool. So you can make this more harsh, or you can make this more smooth. So I like to make this more harsh, so I'm going to use that. You can also promote this, but I'm not going to do that. So how we can basically, if you connect the color mix back, how you can basically like remove those waves, right? So because we don't want to have them infinitely here, and for that, I mean, that's kind of effect itself, but we still don't want this. So we're going to take H, we're going to duplicate this fit range node, but we going to then use a ramp, and this ramp will be basically a fall off ramp shape. This is going to be spline ramp, and then let's actually visualize this. So for now nothing happens because our ramp is empty. Let's use a preset called hill, and you can see that this is basically creates outline. What we need to do is we're going to shape this. So at the first we're going to just make this more harsh, and as it transitions out I'm going to change this to B-spline, and I'm going to use the ramp to like create my own shape, so my own like a F curve. But you can see that if we now use the smooth node and multiply it by this ramp, and then let's remove this, let's bring the color mix back, and you can see that we have a wave, but it's quite like limited, so it's not like, so we don't have waves here, but we want them because we don't want the waves only on the edge. So for that we're gonna have to use a little bit higher value in the width, but we don't want to change the fall off itself. But there's a way you can multiply this width by another parameter, which we're gonna call wave fall off width, and we're gonna multiply this by a bigger value. So for example 2, you can see that if we start play around with this, it actually creates a longer range for the waves, so they basically starts growing like this. Let's increase the displacement scale a little bit so we can see it better. But the next thing what I want to do, it's almost finished, but I wanted to have a in these areas I don't want it to have like fully on mask. I wanted to have more nicer transition using those waves, and for that what I did, I just subtracted the values from this fit range going to mask, and I just subtracted the result of the waves from this mask, so I got this result, and this is quite nice. You can see that it creates more interesting transition for us, and that's quite nice. To make it a little bit more more faded in, what I did was I additionally multiplied the result of this with this ramp, and that's, as you can see, creates more smoother transition here. So that's basically it. And one last thing, you might find those waves are too like regular, too spherical, and there's a fix for that as well. After you multiply your age going to sine node, you can subtract a value, and then you can use a turbulent noise, for example, and the turbulent noise I'm gonna set to 0 centered parallel noise, and I'm gonna just subtract this. You can see nothing really happens, but if we start to increase the amplitude here, you can see they are getting displaced right here. That's exactly what we want, but of course we don't want this to be, you can switch between different noises, that doesn't really matter, but we don't want this to be too frequent, so we're gonna just lower down the roughness here, and we're gonna also use multiply constant, so this will be basically your frequency, right? So frequency, so as you multiply this you get lower frequency or higher frequency, so that's basically it. I'm gonna switch back to 0 centered. I'm gonna just increase this a little bit, and then also you can see that now our transition is a little bit more interesting. but you can animate the offset as well. So if you animate offset, you can see we get additional movement. For that, we can again use the time. So if you directly pipe this, this becomes too aggressive. So I want to animate only one parameter of this offset. So again, I'm gonna use a float to vector. Now I have three different, like basically we just split this offset to three different floats, and I'm gonna also only animate the Y. If you do so, you can see that now it's more organic, but it's too fast for my taste. So I'm gonna divide the incoming time with the incoming time, just divide this by 3 for example, and now it will become a lot more slower, and you can see that this is like basically the final effect that we're after. The only other thing that I did was I added the those sparks here, and that's pretty much it. But there's one more thing always. Last thing you might find useful is basically how we can let's actually make this noise a little bit less. Of course it's too much, like maybe 20 would be enough. Drop, yeah, I think that's fine basically. So we have triangles. The mesh is ugly. We lost our UVs, we lost like everything. So how we can get our nice geometry back, and also of course the UVs and all of the other stuff. So we're gonna use a point deform. So point deform, we're gonna use the static mesh here, and I'm gonna use deformed mesh here, and you can see basically we just transferred the animation back to the original one. But before that, I'm gonna just subdivide this. Still want a little bit more details, but yeah, that's pretty much it. But there's one problem. Where is our attributes? So we don't have any mask attribute that we can use. We don't have any colors. How you can like get those attributes back? And for this also a fix. First of all, you can of course always use attribute transfer, but you know what I'm saying, it's just approximations, we don't want that. So for that we're gonna use ray node. The ray node is really powerful. What you need to do is select your original geo and pipe the collision primitives to the static remeshed variant. Okay, again this bad topology thing. So we're gonna connect this to the static, and then you can see that this gives you those weird artifacts. What you need to do is you need to set the method to minimum distance. You're gonna untick the transform points. We don't want to do that, but we do want to have this ray hit prim and hit prim UV. So we're gonna call this store hit attributes. Basically what it's doing, it's actually saving all of those points, position and primitive numbers in a UV space, kind of, so that we can use these two attributes later to interpolate between the positions. So we're going to use attribute interpolate, and we're going to connect the deforming geo back. What's happening? Okay, it's good. So I'm going to connect this back, but instead of source prim UV, we're going to use a hit prim and hit prim UV. And now you can see you just nicely transferred your attributes, and that's quite nice and quite good looking. So let's blur the position, let's blur the CD, let's blur the mask, just like 1 or 2 iterations, and this is basically your final result. As you can see, it's quite slow because we're doing all of these separations, but you can cache that. You can use this one for the visualization, and yeah, so this is basically the final effect. Before I end this, I just wanted to quickly go through this eagle render that I did, how I made these impact particles, how I transition between different materials, and like just quickly show you the render setup for this. You can see this like quite nice glittery gold shader, and also you have this nice sparkly particles here. So let's look at the setup. Basically these are cameras, these are lights, this is where our setup. You can see it's the same except this part basically sparks. So the way I did this, I of course get my splits. So when the point is actually splitted, what I did was I calculated the velocity. So in here, I'm just saying that let me take the normal that we get from the surface, right? Pointing from the surface, and let me just normalize this. I'm mixing this with the y position, multiplying this, and then I'm using the same technique that I used in this thing, the same technique. I'm just basically shaping this, and what happens is that my velocity gets this, and then it slowly so if you look at this one, you can see this is the velocity. So basically it starts with the higher values, then basically over time it fades, and this is done the same way that we did before in the age attribute setup. So basically in the 6 frames you're gonna just multiply with the 0. And in here I'm also saying that if the value is less than 0.05, just remove the points. So I'm just getting those points which are like bringing in and just dying. So it spawns, it dies, spawn, it dies. The next step is I'm just replicating all of the other points around. So I'm just basically spawning a whole bunch of points around this origin. Doing that using point replicate, spawning 40 points around sphere. This is the scale, and the seed is basically random each frame. So the velocity is quite linear. I'm just adding some values. Basically I'm setting this, but it should be add. But because we're using the direction attribute here, it's gonna just randomize this by cone. You can see that here. So I'm just randomizing the velocities, and I'm also using attribute adjust vector to randomize the length of the vectors. That's pretty much it. Then bringing my collision geometry, my low res geometry, just peaking this a little bit to compensate the particle size, and then using this pop sim. Just here it's simple pop simulation. So what's happening? So what I did was I just put down the ground plane. I just source them. I'm sourcing these all points. Life is 2 seconds, variance is half a second, and then multiplying this by 5, the initial velocity, adding some wind here, adding some pop drag, just a little bit lower down the bounce of the particles, and then in the pop solver I just use the collision behavior, which is slide. So I don't want them to stick to the surface, I always want them to slide. And then in here I just use surface collision and added the gravity. So basically this is what we have. So you can see that they are spawning and then just dying off. So what I wanted to do, I just get from the ID random p-scales. I multiply this with like a global scale, and then I use this old technique age divided by life, fit this randomly, and then basically when my particles die they just fade off. This is the setup basically. Just cleaning the attributes and merging back with the like dropping points you can see here. Those are basically, I'm using the point velocity to calculate velocity for them, which is going to be used later in the render. I also added a p-scale for this, which is plus minus like the same average p-scale here. And I'm just merging them back, and in the end we get this. Boom, boom, boom. Just give this color for viewport and then just cache this out. So this is basically what I get from this. So the setup is the same except this part. This part I show you how you can build this. Also this file would be available on the Gumroad. You can grab it if you want. For the setup, it's just basically one camera. I'm using this null to just like rotate like this. And then I used redshift for rendering. I just split the geometry, particles, and the backdrops to 3 different geonodes. Used two HDRIs, 1 and 2. This one is mainly for the reflection. So if you look at the render here, so let me just turn this off. So this is, let me turn this light off. This is purely reflections almost. This is like overall HDRI, and then the background light here. So it just lit with the 2 HDRIs and 1 background light. In the geometry I used this simple like plastic shader, nothing fancy, and I used this gold shader. In the gold shader I'm just using the texture here, just some smudges from the grayscale gorilla. Put this through a triplanar, and I just made also flakes here. The UV is actually required for these flakes to work. I multiplied these flakes so that they are not that strong, and in the end of course we basically get those flaky like materials. Those flakes, like this gold, kinda looks cool, I think. And then I'm just basically using the mask, my mask attribute, to like transition between those. Where is it? Okay, there you go. So basically this mask attribute that we outputted, I'm using this to like blend between these 2 materials, and that's pretty much it. For particles it's just like incandescent shader, just emission shader, and that's pretty much it. Nothing like fancy.